All right, let's do the discriminant and use it to find out what kind of solutions we have to these quadratics. And then we're going to choose a method that we would use to solve it. So for number 62, this is a quadratic. If you graph it on your calculator, you will see it. If you see where it crosses the x-axis, those are real solutions. But you can also use the discriminant to find what kind of solutions there are. The reason you can do that is because the discriminant is negative b plus or minus, well, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. The reason that the discriminant tells us what kind of solutions we'll have is because it's under a square root. So when you take square roots of negative numbers, you get imaginary numbers. So if b squared minus 4ac is less than 0, meaning it's negative, then it's going to give us imaginary solutions. If it's greater than 0, then we're going to have real solutions because you can take the square root of a positive number and get another real number. And if it's 0, then what happens is that your solutions, usually you have negative b plus a number, you divide it by 2a, and that's one solution. You have negative b minus a number, you divide it by 2a, and you get the other solution. However, if it's 0, then it's just negative b over 2a. You have one number that's your solution. So let's find out what we have on number 62 here. A is negative 8, b is 5. A goes with the x squared term, b goes with the linear term, the x term, and then c is the constant term. You see we don't have a constant term, so it's just 0. So now we're going to plug those in to the discriminant. We will do 5 squared minus 4 times a, which is negative 8, times c, which is 0. Anytime you multiply by 0, what do you get? 0. So it's just 25 minus nothing, which is 25. 25 is a positive number, and so it's going to tell us, or it tells us that we will have 2 real solutions. Okay, and how would you go about solving this if you wanted to find out what those 2 real solutions were? Now, starting off, you could use the quadratic formula because it always works. You could use completing the square because it also always works. However, completing the square is really tough here. The quadratic formula is tougher than it needs to be because this is a perfect one for factoring. Because it has a GCF that you can take out, an X that you can pull out front. And so one of the solutions is 0, and the other one, make sure I don't tell you wrong, is 5/8. So that one's easy to solve by factoring because it has a greatest common factor. Let's do 64. A little more difficult. Not bad though, because if you want to use the discriminant, just like the quadratic formula, it's got to be set equal to 0. So we need to move all the variables onto the same side. We're going to move that 4n squared over, and it'll give us negative 2n squared minus 3n minus 6 is equal to 0. Then we're going to, we got to identify a, b, and c. So a is negative 2, b is negative 3, c is negative 6. We do b squared, so negative 3 squared minus 4 times negative 2 times negative 6. So we get 9. 4 times negative 2 is 8, times negative 6 is negative 48. So this is going to be negative 39 as our discriminant. And that means because it's negative, when we take the square root of negative, we get imaginary solutions. So this is going to have 2 imaginary solutions. Almost forgot, but on number 64, I would use the quadratic formula to solve this because I would have to divide by -2 to start completing the square. That's going to make this -3/2, or -3/2. I'm going to have to square that fraction. It's not going to be as friendly as we want it to be. And then factoring, if I did -2 times -6, I'd get 12. Are there factors of 12 that add up to -3? Not that I can think of. So I would default then to the quadratic formula. But let's do a little bit of factoring. I'll run through these pretty quickly. I'm going to do the evens, starting with number 66. So the thing about factoring, like a lot of these, we want this to be set equal to 0. That's one of the benefits. That's why factoring is so beneficial if it's set equal to 0, because it doesn't matter what the other factor is. If one factor is 0, the whole equation equals 0. So we move the 6 over, we get x squared plus x minus 6 is equal to 0. And now we're ready to rock and roll. So we do a times c, but a is 1. So a times c is just c, it's -6. We need factors of -6. So two numbers that multiply to be -6 that add up to 1. That would be +3 and -2. So we rewrite this, x plus 3 times x minus 2. Now that's factored, but it says solve by factoring. So we have to set x plus 3, one of those factors equal to 0, and solve. Get x equals -3, so that's one solution. Then we set the other factor, x minus 2 equal to 0, and solve, and we get x equals 2 as the other solution. All right, let's do number 68 real quick. Awesome, didn't change colors at all. Number 68, you see it has an x squared and an x term, but it doesn't have a c term. So there are some things that the x squared term and the x have in common. We would call them greatest common factors, and you always look for those, but sometimes they just aren't there. So the numbers 2 and 16, can they both be divided by the same thing? Yeah, they can both be divided by 2. What about x squared and x? They both have an x in them. So the greatest common factor between those two terms is 2x. So then we write some parentheses here. Because we've divided both those things by 2x, we have to show that if you want to get back to the original, you'll have to multiply something by 2x. What do I multiply 2x by to get 2x squared? Just an x. What do I multiply 2 by to get -16? -8. You don't have to multiply x by anything to get x. So you have 2x times x minus 8. And that is fully factored. The left side has been factored. But if we want to find the solutions, we need to take those factors and set them equal to 0. The first one is as easy as it looks. X equals 0. No solving left to do. 2 can't be 0. It just can't. Not even if it wants to be. And then x minus 8, set it equal to 0. You get x equals 8 as the other solution. So these are the two things that you could plug into this equation and it would in fact equal 0. Those are the places where it crosses the x-axis, yada, yada, yada. Number 70. We have all three terms. We're going to look for the greatest common factors. We're not going to find any. And so we're going to do A times C. This time it does make a difference because A is 3. So we get -21. We need factors of -21 that add up to -4. There's some numbers jumping in my head right now. I hope they jump in your mind too. -7 and 3. You want to make sure, double check. -7 times 3, is it -21? It is. -7 plus 3, is it -4? It is. Always check it. That way you know for sure when you bring them back over here that you've got the right factors. So P minus 7 times P plus 3, same way as we have before. However, you might notice right here that P times P doesn't equal 3P squared, which is what we started with. And negative 7 times 3 doesn't equal negative 7, which is what we started with. Why not? Well, because if you remember at the beginning, we got these factors by multiplying negative 7, the last number, by 3. So our factors multiply to something that's 3 times too big. So whatever A was, the 3 in this case, we have to divide both our factors by 3 before we're done with this. We're going to then simplify whatever simplifies. So the 3 over 3 simplifies to 1. But if it doesn't simplify, which this one doesn't, then you do bottoms up. Bring it in front of the P, 3P minus 7. And that will be totally factored. We still want solutions though. And the solutions are, so one of them is negative 1, comes from the second set of parentheses here. And the other one, actually, if instead of solving 3P minus 7 or setting that equal to 0, just look back up before you did the bottoms up method. There's your solution, but it's positive 7 over 3. So you can set 3P minus 7 equal to 0 and solve for P, but I just want you to know you've already got it right there. 7 over 3. 72, our last factoring job to do here. I'm going to see if these things will divide by anything. I'm thinking 7. There might be something else, but I'm thinking 7. And so you might just pull your calculator out and say, hey, 21, I know that that thing divides by 7, pretty sure. And then look at 119. See if it divides by 7, and it does. And then look at 196, see if it divides by 7, and it does. So we can factor out a 7. Quite lovely. And if you want to know what's going to be left in there, boo. The lag got me finally. You got 3x squared plus, remember our calculator just told us these things, 17 and 28. 17x minus 28 equals 0. Now don't give up here. We still need to factor some more. So there's no more greatest common factors. We're going to have to do A times C. Come on. So we do 3 times negative 28. We get negative 84. We need factors of negative 84 that are going to add up to 17. And we finally arrived at one that is tough enough that you might want to use a calculator for this. Okay. You remember, you go to y equals and type in the number you want factored. So negative 84 in this case, divided by x. If you hit second and graph, it will take you to all those factors. So every row of this table is going to tell us 2 factors of negative 84. We just have to find the right ones. So I'm going to go upwards, and I'm looking for ones that add up to 17. And I do believe I just found them at negative 4 and 21. I know negative 4 times 21 is negative 84. And then I can check them. They do add up to 17. So I come back over here. I rewrite my 7 because it's still there. It still matters. We have x minus 4 times x plus 21. We still have to divide those factors by a, whatever we multiplied by. So 3 in this case. We get x plus 7. That one simplifies. And then this one doesn't. So bottoms up. 3x minus 4. One last time, we want the solutions. We want to know when will this quadratic equal 0. And if I gave you that problem at the beginning and said, when is this going to be equal to 0? I'm sure you would have given up. But now that we've got it factored, if x plus 7 is 0, doesn't matter what the rest is. This whole thing's going to be 0. Because if you multiply by 0, you get 0. So one solution is -7. And the other solution is, look at the before you bottoms up, did the bottoms up, -4/3. It's actually +4/3 is the 0. And that is factoring. We're going to keep going here. We're going to knock out some quadratic formula. I wrote the quadratic formula on a previous video, but it is -b plus or minus the square root of b squared minus 4ac all over 2a. That is, if you take a, b, and c, which are unique for each quadratic, and you set them equal to, or you put them in the quadratic formula, it'll tell you the x values that give you that true statement that make the whole quadratic equal to 0. But if you look at 73, the first thing you have to do is set that equal to 0. So we need to move the 11 over to the left side. Get that thing set equal to 0. Then we can start plugging things in. You have to know that a goes with the quadratic term, the b squared. So that's 9. B is -11. And c is -1. So then we plug things in. So -b, that's -11, which is +11, plus or minus the square root of -11 squared minus 4 times a times c. All of that over 2a. Then it's time for us to simplify this a little bit. So 11 plus or minus 2 times 9 makes 18. And this is the square root of one single number. So I'm going to go find that number. We'll do -11 squared. Notice how I put that in parentheses. Minus 4 and 9 times -1. And that is 157, which seems kind of prime to me. I think it is. So if I want to know if there's any perfect squares, 157 divided by x, go look in the table. 1, no, doesn't help. 4, no. 9, no. 16, 25, nope. 36, 49, last hope. I surrender. There are no perfect squares. So there are two solutions built up into this: 11 plus the square root of 157 over 18 and 11 minus the square root of 157 over 18. What I'm going to do is give you some numbers that make sense to us and see what those solutions are. So let's do 11 plus the square root of 157 is 12.52 blah, 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 blah. Hit enter. We're going to divide that by 18 and you get the number 1.31. That is one of the solutions. You plug that in for B in the original equation and this thing will equal 11. Or 11 minus that square root of 157 divided by 18, get a smaller number, -0.085. -0.085. Those are the solutions to that quadratic. All right. I'm going to do one more with my guest star, Audra, if she'll allow it. Baby girl. So number 76, you have an A value of 1, B is 4, and C is also 4. So negative B is negative 4 plus or minus the square root of B squared. So that would be 4 squared minus 4 times A times C all over 2A. Hey, don't mean that. I'm recording a video. It's loud. Okay, so we simplify then negative 4 plus or minus the square root of 4 squared minus 4 times 4 is just 0 over 2. So this number 76 is what it looks like when you have a discriminant of 0. So you see that our answers are negative 4 plus or minus nothing. So there's no need to write it, all divided by 2. So the answer is negative 2. Bye-bye.
I would like. Yeah, I will color.